I just gave a talk to the July 11th, 2017 meeting of the Boulder Python Meetup. And the talk was about the collections from the Python collections module of counter and namedtuple. So I got some slides from a screen share that I'll show along with the audio that I recorded live during the presentation. So I'll show that to you right now, and afterwards I'll go ahead and do a debrief about what I think went well and what I think could have gone better in respect to my delivery of the talk. So I just want to talk about a couple of things. Python dictionaries are great because they let you map keys and values together, key-value pairs. But sometimes you don't need everything they have to offer. Sometimes you don't need the mutability. Sometimes you want more functionality out of it than you might already have. So I pulled a couple of things from the Python collections module. One is called counter, the other is called namedtuple. And want to show those to you tonight so that maybe you could use them in your own programs. I use namedtuple quite a bit, and counter is kind of fun if you want to count words in a document. All right, so counter is the first one we're going to talk about. So basically, there's a use case sometimes where you just need to account the occurrence number of a particular key. Like if you have this isn't a strict natural language processing framework, but if you had some sort of document, you want to count the words in it, maybe sort them out by the most common appearances, you could do that with the counter. Now you can manually do a lot of that with the dictionary, but the key is that the counter will help you do that automatically. So let's just look at a typical dictionary application here. So what we'd have is we just count off each word. Each word would be a key. And we store that as a key value pair, with the value being the number of occurrences of the word. So on our first line, we make a new dictionary. On the second line, I made a sentence of the quick brown fox jumped over the lazy yellow dog, and did quick twice, so I'd have two of the same word. For each word in the split sentence, so I split it on the spaces. It goes through, and if it finds that key already is in the dictionary, it just increments that value by 1. If the key is not in the dictionary already, then it sets that key have a value of 1 already. So you just make sure you keep incrementing an integer value. And so if you run all that over this sentence, then you get the result of this dictionary. And so quick was, we see there, it appeared twice. And everything else is just once. But if we just look at the number of lines in there, everything underneath the 4 is pretty much just dealing with the dictionary. So of course, the potential issues are your manual management of these things, which in this case isn't necessarily that big of a deal, although sometimes it's nice to shorten up code, if not just for readability, but also a couple less lines to maintain. So then this brings us to counter. So basically, the cool things about it are you do not need to initialize each key before it's used. And you do not need to test for the existence for that key, and it will also just make sure it's always an integer, which I think is best shown with an example here. So the first thing you need to do to use the counter is up here. You need to go into from collections import counter. Collections is a module that's built into Python 2.7 and 3.6, and I can show it to you a bit later real quick. It has a bunch of other collections that you can use besides just list and counter. And so you just instantiate a counter next, and then I made another sentence, of the quick brown fox jumped over the lazy yellow dog. So now I have a few more population counts to do. And then it's just a matter of splitting that sentence on the spaces, iterating over that list that split provides, and then with each of those things, all we need to do is hit count word as the key plus equals 1. If it doesn't already exist, then it puts that in the counter for us. Then if we look at the result of this, and also just notice all this white space down there, that's code we didn't need to write. Then we get a counter output, which then, quick is represented 3 times, the is represented 2 times, and the rest of them just occurred once. Now, one of the other cool things with counter, I think, are that you can do the most common. So if you want to get the most common 2 occurrences, in this case, you just do the counts.mostcommon 2, and it gives you a list of tuples, with the first element of the tuple being the key that was passed, in this case the word, and then the second one being the number of occurrences of that was found. So for the counter, it's good for counting occurrences of a key. Let's see here. Sorry if it's just a bit small. So, and it's part of these Python collections. So let's keep going on to another one of the Python collections. And do named tuple. And so if you recall that tuples are just immutable collections of objects, and they can't be, they're immutable, so they can't be changed. And they're kind of cool because they're small and they don't have a lot of functionality, so they're a nice small instance to work with. But they can be kind of inscrutable if you're trying to use them in some of your programs. So they're not a direct competitor to dictionaries, but often what you want to do with dictionaries is just take a human readable, word, map it to a value. Maybe that's not a string like you would take an index into a dictionary with, but you at least want something to look at in your code that's easy to read. And so the advantages with this approach is that you wouldn't need to instantiate a dictionary and then worry about something changing it down the road. But the name tuple does all that and gives you some property names. It also has all the other things that you'd have for a tuple. So if you've ever seen in, say, a for loop where you'd have for x comma y, where those could be 2 variables, where it's actually taking something out, and that iterator on the other side, even though you might not be seeing it, is actually just popping off a list of tuples into that for loop, and it's unpacking them in 2 variables. So you can unpack tuples that way. You can iterate over the tuples themselves, or you can go in with indexes into them like you would a list. And so a named tuple takes that one step further, and then you can add custom property names to it. So it's actually fairly simple. So up here, you import named tuple. From collections, import named tuple. And then the syntax took me a bit to get used to. So you just give it a class name here on the left of like, say, color in this case. I'm going to make a named tuple that holds RGB values. And then you tell again what its name is on this side in a string. Then you give another tuple of property names. And then you can go ahead and just say magenta equals color red, red blue, green, yellow is red 1, blue 1, green 0. Actually, that's not right. It should be green 1.0. I apologize. It's been too long since I've taken art class like mixed paint. That was back when I was in kindergarten and had involved finger paints. Yeah. That's why I write code now. Okay, so anyway, so if you're to use these like I define them on this screen, and go to the next one, and just type this in. So if you're in Jupyter or IPython or just printed it out, you could find out that that's a tuple of color, whatever, and then so yellow's that, magenta's that, and then you can pull out the specific property for a color component. So like magenta.blue is 1.0. Oops, going the wrong way. So here's the next part. You can't set bad property names. And I think this is very key. With dictionaries, you can set pretty much whatever you want on it, just with a plain vanilla dictionary. That can be a bad thing if you mistype the key name, or if something goes in that you're not expected. And if that happens, that could cause a silent failure in your program. Why didn't this show up? Well, in this case, your interpreter will just crash, which tells you what just happened, which is actually good. Of all the errors I find, silents are the worst. And so in this case, I got confused and thought that I was doing RGBA color specification. So I wanted to put an alpha transparency channel on that. Didn't let me do that. Now the other thing, and this is why I said it's not directly competitor to a dictionary, it just gives you a nice friendly word to read in your source code. You can't use a string for it. So you can't just give it, like a dictionary with square brackets has a string. You must use the magenta dot whatever, or the actual property on the tuple. And it will give you this kind of weird error message if you try to do it. Tuple indices must be integers, not string. Just know that you're using a named tuple, so that could be a named property as well. So once again, it's sitting there, named tuple has your named properties on it, and then it's available in Python 2.7 and 3.6. So what I'd like to do is show you real quick. So I just have these named tuples, and there's nothing really much to show you past there. However, what I did do, one of my favorite stories is in classic literature is Alice in Wonderland by Lewis Carroll. And so I went to Project Gutenberg, which has a bunch of out-of-copyright plain text books, and I downloaded the Adventures in Wonderland text. And so this is very slightly more complicated. So I imported string to give me some extra secret sauce here. I made my new counter. I opened up the text file, so with open file name as text file. Then go iterate over each line in the file, and then I take each of those lines and I split it on the spaces. I remove all the punctuation around it, and then I just use this counter to go over each word in the counts. And so then, because the tuple's nice and the counter's nice enough to give you a list of common occurrences if you use the most common method, you could do, say, grab places 290 to 299, I think is what that comes out to be. So U appears 14 times, screaming in all caps. Dodo is 13. But the one I was really interested in is one of my favorite characters in the book, the caterpillar. I don't really know why, but that's just what I remember from the story, which appears 26 times. And I think that right there was worth all the hassle of using the counter. For me personally, that's it. So, does anyone have any questions on that? Oh, yes. What if I wanted to be case insensitive? On the counter, what I would do personally is just go ahead and before I inserted each word, I'd make it lowercase or uppercase, whichever you prefer. I prefer uppercase, so everything is screaming at you. And it looked like old school SQL or Fortran. Any other questions? No? Okay, cool. Well, thanks. Hopefully you find some sort of counter fun stuff to use in your code or named tuple. And I'll hand it back to Ian. So there the talk is. Now, number one, the first thing that comes to mind is I don't necessarily work as well as I want to with slides. I prefer to do code-alongs. And in retrospect, I probably would have had enough time to do that. The reason I was going with slides was because I figured it was a short talk, only about 15 minutes, and I needed to put in as much as I could in as efficiently as I could. But slides, there's still kind of a thing where I am still working at trying not to outpace my slides, trying to make my points in sequence with the slides, not just reading the slides to the audience, etc. It just works out better for me right now if I do live coding and can talk about what I'm writing as I'm writing it. Other than that, I got to meet a few people in the audience, learn a few things that were related to the topics I talked about, which was really cool. And I really enjoyed the experience, even though I could have made it better. So thank you for watching this. Thank you for watching the talk. And I will see you in the next video.